Hi, in this video we're going to look at some triangle sum inequalities. My first question though is, can any three segment lengths be connected to form a triangle? So in other words, if I just randomly looked around my office, my classroom, and I said, let me find three straight objects and can I make a triangle? We kind of usually will go, well yeah, that makes sense. So let's just kind of investigate that, okay? So let's say I'm looking around my classroom and I see, okay, I've got a pencil, and let's say I've got this pen, and then let's use this marker, okay? And I have this marker. I might need to zoom out to see if I can make a triangle, okay? So let's see, can I make a triangle? Well, of course I can, right? So it looks like, you know, if you have three objects, you can make a triangle. But let's keep investigating and see. So I'm going to stick with that pencil, and then I have this little pink, it's actually from a Q-tip that I was using for something else, for another project, that I took the little puffs off the end so that I could have a little segment to use for something else. And then I have a piece of pencil lead that came out of a mechanical pencil. So I'm going to move that to the other end so I can try to make a triangle. And I'm going to, all right, so I just need to connect my pencil lead and so that I can make this triangle. Am I going to be able to make a triangle here? So I can put these all the way in. They're never going to meet each other, right? They're too short. So when we look at it this way, can I really use any three segments to make a triangle? Not if two of the segments are too short to match with the third one, right? These two are going to have to, if I put them together, are going to have to be longer than this one, because they have to meet. They can't be exactly equal, because if they're exactly equal, then they would be right next to each other. They wouldn't actually be able to push out to make that third vertex, right? So they have to be more than equal to each other, okay? So let's look at what we just discovered. Okay, so no, I can't make a triangle with just any three segments, right? So when it says, can any three segment lengths be connected to form a triangle, my answer is going to be no, right? We just showed a counterexample. So I'm going to say no, and just so if you look back in these notes and you want to remember, I'm going to do it in as close to matching colors as I can. We had the pencil, which was yellow, but I'm going to do it in orange. And then we tried to connect the little Q-tip stick that was pink on one end. And then we had our dark gray, so I'm just going to use a black pen, pencil lead. And we said, oh yeah, those aren't going to reach each other. Okay, so no, we can't always just put any three side lengths together to form a triangle. Okay, so here's what we're going to find. Our third side must be between the difference and the sum of the first two sides. So when we do this for a third side, I'm going to use a variable of t. And I put a little like tail on the bottom of my t, like it's italicized kind of, so that way I don't accidentally, if I'm working with it, think it's a plus sign. Because in math, you know, we have plus signs everywhere. So that third side has to be between the difference and the sum of the first two sides. So remember, difference means to subtract, and the sum means to add. So if I look at the difference, if I subtract the first two sides, and the sum, if I add the first two sides, that third side has to be right in the middle. So we write it as an inequality. We look at the smallest value is the difference, the biggest value is the sum, because we're always using positive values because they're side lengths. And then my third side has to fall right in the middle. So the difference is going to be smaller than the third side. So I'm going to use a less than symbol. And then the third side has to be smaller than the sum. Okay, so we're going to look at this inequality to work with this theorem that we're looking at. Okay, now when you look at difference, the only thing I want to note is it has to be a positive difference. Okay, so if you're given two numbers like 4 and 9, you don't want to do 4 minus 9 and get a negative 5. You want to make sure you get the positive difference. So when I say what's the difference between 4 and 9, if I have $4 and you have $9, what's the difference? You would just say $5, right? You wouldn't say, oh, negative $5. You would just talk about how many positive dollars the difference is. So we always want to make sure we're looking at a positive difference here. Okay? All right, so my first three problems I have here say, can triangles be formed using the following measurements? And I'm going to use this inequality to test a third side and see does it fall between the difference and the sum. Okay, so I have three sides. I can pick any of the three to be my third side. Convention tells me I'm just going to use the third side and call that the third side. Okay, but I could have used the 7, I could have used the 5, it doesn't matter. Okay, so I know this needs to fall between the difference and the sum. So I'm going to look at the difference between 7 and 5, and then I'm going to look at the sum of 7 and 5. The difference in 7 and 5 is 2, and our units are centimeters. The sum of 7 and 5 is 12 centimeters. Does the 3 centimeters fall in between? If I put a less than here and a less than here. Is 2 less than 3? Yes. Is 3 less than 12? Yes. So yes, these three side lengths will make a triangle. Okay? When I look at the next one, 12, 6, and 4 yards, again, I'm just going to use the third one as my third side, but I could pick any of them. 12 and 6, I'm going to look at the difference, and I'm going to look at the sum. So 12 minus 6 is 6 yards, and 12 plus 6 is 18 yards. Does the 4 yards correctly fall in between 6 and 18? So is 6 less than 4? No, 6 is not less than 4. So that means that no, I'm not going to be able to make a triangle out of 12, 6, and 4. I don't even have to check the other side. Okay? All right, so next, let's look at 9, 4, and 13. And again, I'm just going to use my third side as my third side. The difference in 9 and 4, the sum of 9 and 4. So 9 minus 4 is 5 feet. 9 plus 4 is 13 feet. Does my third side fulfill my inequality? Less than, less than. Okay? So as we go through and we look at this, 5 feet is less than 13 feet. Yes, that's true. 13 feet is less than 13 feet. That's not true. 13 feet is equal to 13 feet. So that is not true, which means, no, I cannot create a triangle out of 9, 14, and 13. Okay? Sometimes we're going to be asked to give all possible values of two given lengths. When we're asked to do that, what they're looking for, when you see give all possible values, we're looking for that inequality. So I'm going to be looking to give an answer that looks much like this, but with numbers for my difference and my sum. Okay? So I want to know, what is this third side going to be? Okay? So I know I'm going to look at my difference between 8 and 11. I want to do the 11 first because it's bigger, and I want to get a positive difference. And then I'm going to do my sum of those two, and then it doesn't matter if you do 11 plus 8 or 8 plus 11. I just kind of like to stay consistent. So 11 minus 8 is 3, and we're looking at inches. 11 plus 8 is 19, and we're looking at inches. So I know that my third side T is going to fall in between the 3 inches and the 19 inches. Okay, and so it's right here. And the reason we have to leave our answer like this is because it's impossible to list every value that would work, because you would kind of think, oh, I just list 4, 5, 6, 7, 8, 9, all the way up to 18. But remember, side lengths can be decimals, right? I could have a side that's 4.2 inches long. Well, that would work. I could have a side that's 18.5 inches long. That would work, right? So you can't write every decimal answer down. So we write it as our inequality. All right? Let's look at the second one over here. I'm going to do the same exact process. I'm going to figure out what am I going to put for my third side T. Okay, so I'm going to look at my difference between 25 and 15, and I'm going to look at my sum of 25 and 15. When I look at that, I'm going to subtract here and get 10. My units are meters. And when I add here, I'm going to get 40. And again, my units are meters. And I'm going to put my third side in between. 10 has to be less than t, which is going to be less than 40. So t has to fall somewhere between 10 and 40. Okay? Alright, so there is your triangle sum theorem, looking at how big your sides can be, okay, when you're trying to create a triangle. Next, what we're going to do is we're going to look at angles and side lengths of triangles to see if we can order them from smallest to largest or largest to smallest. Thank you so much for watching.